What is retrieval-augmented generation? Let's talk about something that's transforming the way AI systems understand and respond to our queries. Retrieval-augmented generation, also known as RAG. To begin, let's break down the name itself. Retrieval-augmented means that the system pulls in or retrieves external information. Generation refers to how an AI model like GPT generates text. So when you combine the two, you get an AI that not only understands language and generates responses, but also has access to external data sources it can retrieve from on the fly. Now, why is this important? Traditional language models, like the ones many people are familiar with, rely on what they've been trained on. They learn from massive data sets collected during training and then generate responses based on that knowledge. But here's the catch. They don't know anything that happened after their training cutoff date. They also don't have real-time access to evolving information. This can lead to outdated or inaccurate responses. That's where RAG comes in. RAG enhances a language model by giving it the ability to search through a database of documents or even the internet before generating a response. Imagine asking a question about the latest research on cancer treatment. A standard model might give you a general idea, but a RAG-enabled model can retrieve recent journal articles, extract relevant insights, and then craft a much more accurate and up-to-date answer. Here's how it works under the hood. When a user asks a question, the system does two main things. First, it uses a retrieval component, typically a vector database, with embeddings, to search for documents that are semantically relevant to the query. These are not just keyword matches, but are based on meaning and context. Second, it passes those retrieved documents to the generative language model, which reads them and uses the content to craft a coherent and informed answer. This fusion of search and generation is powerful. Think of it like this. Instead of relying solely on its memory, the AI now has a dynamic library it can consult before answering you. Now let's dive a little deeper into the retrieval part. The system uses something called embeddings, numerical representations of text. It takes your question, turns it into an embedding, and then compares it with the embeddings of millions of documents to find the ones that are most relevant. This is done using fast and efficient similarity search algorithms. Once the documents are retrieved, they're fed into the generation model. This model then uses that real-time context to generate a response. This process enables the AI to answer questions it couldn't have possibly learned during training, especially when the information is new, specific, or domain-dependent. A great example of this in action is in customer support. Companies can use RAG-based systems to answer customer queries by retrieving the latest help articles, user manuals, or policy documents, and then summarizing them into clear, conversational answers. This eliminates the need for users to search through pages of documentation themselves. In healthcare, a RAG system can help doctors get the most current medical guidelines. In law, it can provide up-to-date regulations or case references. In research, it can help scientists stay on top of the latest publications. The possibilities are vast, but it's not without challenges. One major challenge is ensuring that the retrieved documents are accurate and relevant. If the system retrieves the wrong context, it might generate misleading responses. Another issue is latency. The process of searching through large datasets can take time. That might slow down the user experience. Moreover, managing and curating the retrieval database is crucial. If it's not well maintained or if it contains biased or low-quality content, the system's output will suffer. There's also the question of source transparency. Users need to know where the information is coming from, especially in critical fields like law, medicine, or journalism. Many RAG systems include references or links to their sources so users can verify the information themselves. So, to sum it all up, Retrieval-Augmented Generation is a hybrid approach that combines the strengths of two powerful technologies, search and generation. It allows AI systems to become more accurate, more current, and more useful by integrating real-time or external knowledge retrieval into their response process. It's like upgrading a student who memorized textbooks to one who also knows how to use the library effectively. The result is a much smarter and more capable assistant. As we continue to demand more from AI, especially in fast-moving or knowledge-heavy domains, RAG will likely play a critical role in building systems that are not only intelligent, but also well-informed. And that's what makes Retrieval-Augmented Generation such a game changer in the evolution of artificial intelligence. Like and subscribe to help the channel grow. Cheers!